Selective coordination in electrical systems ensures that only the protective device closest to fault opens, minimizing disruption. Resources for understanding selective coordination include IEEE Standard 242.2001, which is a guide for protection and coordination of industrial and commercial power systems, and the National Electrical Code, specifically Section 240.12. The National Electrical Code provides requirements for selective coordination of overcurrent protective devices in industrial installations. In some scenarios, using both a circuit breaker and a fusible disconnect is necessary to achieve selective coordination. There are a couple reasons as to why this may be the case. Firstly, fuses typically possess a higher interrupting capacity. This means they can handle larger fault currents compared to circuit breakers, providing better protection against significant electrical faults. Secondly, fuses can be designed to introduce a time delay before tripping. This time delay allows downstream protective devices closer to the fault to clear the fault first, preventing unnecessary tripping of upstream devices. Therefore, in specific cases, a fusible disconnect alongside a circuit breaker enhances selective coordination. Other methods exist to achieve selective coordination without additional equipment. Firstly, utilizing current-limiting devices can be very helpful. Current-limiting circuit breakers or fuses can reduce the fault current available to downstream protective devices. This reduction makes it more likely that the downstream devices will trip before the upstream device, achieving coordination. Secondly, setting time delays on protective devices is another effective strategy. By intentionally introducing a time delay between the tripping of different protective devices, selective coordination can be achieved. This ensures that the device closest to the fault responds first, limiting the impact of the fault. Thirdly, using low impedance buses can improve coordination. Low impedance buses reduce voltage drop during faults, which can allow downstream devices to trip faster. This faster tripping contributes to better selective coordination throughout the system. In summary, to achieve effective selective coordination, one should consider these points. Section 240.12 of the National Electrical Code addresses selective coordination requirements. Fuses are often used in conjunction with circuit breakers because they offer a higher interrupting capacity and can be specified with time delay characteristics. Current-limiting devices such as fuses and circuit breakers are also used to minimize fault current. Adjusting the time delay settings on protective devices can also facilitate selective coordination. A low-impedance bus system will experience less voltage drop during fault conditions, enabling downstream devices to react quickly.